The freezing point of a substance will depress or go down when another substance is dissolved in it, similar to the way the boiling point will increase when another substance is dissolved in a pure substance. In order to measure the freezing point, we need some temperature measuring device. Here we set up a lab pro with a temperature probe. We could also use a thermometer. First, we measure the freezing point of a pure substance. We measure out the pure substance on a balance so that we know how much we have. We set up a hot water bath to completely melt the pure substance. After the substance is in its liquid form, we'll allow it to cool while monitoring the temperature periodically. The advantage of using the temperature probe is that we can use the Logger Pro software to read the temperature and make a graph for us as the temperature cools and the substance freezes. In our first trial, we find the freezing point of the pure substance, the solvent. To get the best results, we try to allow the substance to freeze slowly and evenly. We must continue stirring it so that the cold doesn't begin too much on the outside. In our second trial, we melt the solvent and add a solute, which should lower the freezing point. In this experiment, we use an organic solute, which will not dissociate. Thus, the Van't Hoff factor will be 1, and our calculations will be simpler. Once the solute is dissolved, we again let it refreeze, taking the temperature and using the Logger Pro software to get a graph. The freezing point will go down or be depressed because of the presence of the solute. This freezing point depression is called a colligative property. The data from this experiment will allow us to calculate the molar mass of an unknown substance. In this equation, delta T is the freezing point depression, or the amount the freezing point of the mixture deviates from the freezing point of the pure substance. I is the Van't Hoff factor, K is the freezing point depression constant of the solute, and M is the molality of the mixture. Once we calculate the molality, we can then calculate the moles, knowing how much of the solute we started with. And then, knowing the mass of the solvent we started with, we can calculate the unknown's molar mass.